Okay, so this is the final type of transformation that we're going to be doing, and this is not a congruence transformation, although I'm not going to ask you that question. If you look back actually into when we did similar figures in 7th grade, this will look, well, similar to that, the same as that. So a dilation is a transformation that produces an image that is the same shape, okay, as the original, but it's not the same size. Okay, so a dilation is similar to the original figure. It's not actually going to be congruent, all right? And all of our dilations will be around the origin. None of them will be around any other coordinate. Okay, so you'll remember, hopefully, the term scale factor, but if you don't, you learned that in 7th grade. So it's just I don't even like that word. So it's the image length over the pre-image length. So it's a multiplier, it's a factor that scales something up or down. So if it's greater than 1, the figure becomes larger or bigger. And if that scale factor is between 0 and 1, the figure becomes smaller. Okay? So these pieces are just kind of to be clear on what happens. I'm much more concerned about the rules and that sort of thing. So you'll remember f of x and f of y from this year were, in this case, they're using f representing the scale factor, but you can kind of think of it as even a function of. So x, y leads to a simple function multiplying by something. So if the scale factor is 3, how would I write that? Well, x and y become 3 times x and 3 times y. That is really all that means. So f was the scale factor in this particular case. So the function is a multiplication function. Okay, so if this happens, a scale factor of 4, all I need to do is take these numbers and multiply each of them by 4. So remember that we're going to look at this is our pre-image. And this here will be our image. And remember that we show that by prime. So a prime, we're going to multiply both of these by 4. 0 times 4 is 0. 2 times 4 is 8. Okay, and I will change color because it's more fun that way. And I don't have any fun nail polish colors right now. So b prime multiplied by 4 again. 16 and 16. And the final one, c prime. Okay, so there's my 3 coordinates. I'm not going to graph them right now. This is really the easiest way to think of dilations, though, is just to multiply or divide or multiply by a fraction, something that's between 0 and 1. Think of it as all as multiplication, but you certainly can divide. All right, now these are going to be actual problems where you are looking at graphing them. So the very first point in the beginning diagram or the beginning shape for quadrilateral. Okay, so 4-sided figure, vertices of -2, 4. So P is at -2, +4. So here's my original. So I'm going to graph my original, 4, 4. And for -2, okay, in this particular quadrilateral, and -4, -4. So came close to a rectangle, but that's why it's just a quadrilateral. So we're going to graph this. Okay, and then you're going to show where the new figure is under the dilation. So here's the original, kind of a kite figure. And I like dilations because they can make kind of different size shapes. So it's dilated by a scale factor of 1/2. So we can think about multiplying those each by 1/2. So we're going to do P prime. So if I multiply negative 2 by a half or divide it by 2, it's going to be negative 1. 4 divided by 2 is 2. Q prime. 4 divided by 2 is 2 again. Divide this one by 2, 2. So in each case, I'm dividing by 2 or multiplying by a half. In both that and that case. That's kind of me showing work. Okay, R prime. 4 divided by a half is 2. Negative 2 divided by a half, divided by 2 is negative 1. And S prime, negative 4 divided by 2 is negative 2. And the Y value is also negative 2. All right, so I'm just going to graph that. Negative 1, 2. So negative 1 up to 2. So here's P prime. 2, 2. Which is Q prime. 2, negative 1, which is R prime. And negative 2, negative 2, which is S prime. What I like about these, though, is that you can kind of see that similar figure, and you can make kind of neater figures when you do dilation. Because you can change the size, whereas all of the other transformations that we've done only move the shape. Okay, no changing of the size. All right, so there's my final figure. Those are my coordinates. You do not need to worry about demonstrating that things are similar. You would have to compare every ratio and similarity with something we really discussed last year. And if you would like to talk about the angle measurements, go right ahead, but similar figures should have the same angle measurements. But that is not a major concern right now. So I just am worried that you understand how to dilate a figure. So next example. If the scale factor is 5/2, how would you write a general rule? And is that going to be an enlargement or is that going to be a reduction? So I'm just going to write the general rule of xy, 2 5/2 x and 5/2 y. And as 5/2 is larger than 1, it's an enlargement. If you would like to change these to decimals and write it as 2.5, that's fine. If you want to write it as 2.5 as a mixed fraction, that's also fine. I prefer to just leave it as is. Okay, this one here, you have to be super careful that you pay attention to which one is the original and which one is not. So remember that the original, this A, B, C, D, these are the original points because that's how we determine what the pre-image is. There's no prime. Okay, so this has been a reduction. Okay, so we've made this smaller. Okay, and what is the scale factor? Well, I went from 6 to 2. I went from 6 to 2 here. I went from negative 6 to negative 2. And I went from negative 6 to negative 2. All of the other values are 0. So like if I take an example, so I go B was 0, 6, and B prime was 0, 2. And let's take one that's has an x value of positive 6, and A prime is 2, 0. Okay, so I've divided by 3, but we aren't going to write it that way because in math we have come up with a convention that everything is multiplication. So when we divide by 3, or divide by 3 over 1, remember from 6th grade math that is the same as multiplying by a third. Okay, so the way we're actually going to write the rule here is xy goes to 1/3 x, 1/3 y. Now it didn't actually tell you had to write the rule. It actually said you needed the scale factor. Well, the scale factor is 1/3, and we did that last year as well with scale factors. Okay, so this is kind of the one that really goes back to similarity and talking about similar figures. All right, one more example. Okay, and this one is already drawn for you, but they want you to draw a triangle x prime, y prime, z prime. Here's x, y, z. And you need to use a scale factor of 2. Now, Me personally, I prefer to actually write the original coordinates. So the original coordinate of x is -1, -1. The original coordinate of y is -1, 2. And the original coordinate of z, and the only reason I'm crossing that is so it doesn't look like my 2. Okay, so you can tell it's a z and not a 2. I don't normally do that with my numbers. Okay, so now I have to do this in a scale factor of 2. So I'm going to multiply this by 2, and I'm going to multiply that by 2. Okay, so x prime will be -2, -2. Y prime will be -2, 4. And z prime will be 2, 2. So -2, -2, -2, and down to -2. Here is x prime. -2 and up to 4. Here is y prime. And over to 2, up to 2 is z prime. Okay, so this one I have learned finally, after all this time, to actually have a ruler right there, because that's super important for making these look good. However, you don't have to be really concerned about that. If you don't have a ruler at home, just be concerned that the coordinates are correct. So there's my final graph. And this specifically asks for a second portion, but I'm not going to do that because you're going to do additional reflection pieces later on and put that together. So I just want you to focus on dilations. So there you go. There are some dilations, and we will do compositions of all of these after you're comfortable with dilations. All right, so do some practice. You've got a day for practice, and then we'll put it all together. Have a great one.